Today, we are going to evaluate the integral of arccosine of x using integration by parts. Integration by parts is a technique derived from the product rule for differentiation. It states that the integral of u dv is equal to v minus the integral of v du. All right, let's begin. First, we need to determine parts of this integral. We'll choose u to be arccos of x, which means du is the derivative of arccos of x with respect to x. For dv, we'll choose plain dx, so v is simply x. Next, let's compute these parts. The derivative of arccos of x with respect to x is negative 1 over the square root of 1 minus x squared. For v, the integral of dx is simply x. Let's solve for v and du. Now that we have u, v, du, and dv, we can place them into the integration by parts formula. This formula is uv minus the integral of v du. Substituting in our values, the expression becomes x times arccos of x minus the integral of negative x over square root of 1 minus x squared. Simplifying, this is x times arccos x plus the integral of x over square root of 1 minus x squared. Now let's handle the remaining integral. Notice that it's suitable for substitution. Let's choose substitution method, letting t equal 1 minus x squared, which makes dt equal negative 2x dx. Solving for dx is negative 1 over 2x dt. Make the substitution. Substituting into the integral, the remaining integral becomes the negative 1/2 integral of t to the power of negative 1/2 dt. Finally, applying the reverse power rule to integrate t to the power of negative 1/2 yields 2 square roots of t plus a constant c. Bringing it all together, the integral of arccos of x dx equals x arccos x plus the negative square root of 1 minus x squared plus c. And that's how you evaluate the integral of arccosine of x using integration by parts.